going to talk about the sharding. So what is the sharding? I think the pronunciation is right. Let me check.
Sharding.
Sharding, yeah. Sharding is horizontal partition across multiple machines. Each shard holds a subset of the data, and together the shards make up the full data set. Unlike partitions, which stay within a single database instance, sharding separates the load access many independent databases. For example, if we partition our order data, right, by ID, we might end up with something like this one. So based on the ID, there has the same data structure in the three database. Just based on the different like user ID, they were different things. So we can treat like you have the very large table, and the stuff from the order 1 to the 10 is put in the first table, going to the first page, and then you have the second page, right? It's kind of like here. That is put in the second database. So this is the meaning of the sharding. So why we need it? Because it needs to solve some problem. For example, when your application is the takeoff, right? For example here, right? So we have the clients and the server database. We have the 70 TB, and this is the information about the database is okay, right? But when you have like more than this is called what? Yes, at the beginning, right? So when you get the database keep bigger, right? You have more access. The storage approach the 70 TB. Then it will encounter some problems. Like you can say there, at first you solve this by upgrading to a larger database instance with more CPU memory and storage. This works for a while, but eventually you hit the ceiling of what the single machine can handle. Like query slowdown, write becomes bottleneck, and the storage approach the limit. And even powerful cloud database like Amazon, it still have the limit, right? Storage here. So when you can achieve this one, it's okay. So you large your database. But finally, you always will achieve something. Maybe current here, you become very popular in the world, in the global world. So every different country wants to access. You cannot do this anymore. So we have to use this solution to split your data across multiple machines, which is sharding. Like here, you have to create multiple database, and based on some like kind of like index or some shadow key, and separate them into different database and let the user to access. So the problem become how to shard your data. So we have how to pick up the shadow key. We have some like a good way to pick up. The first is high coordinate. How do you say coordinate? I'm not sure pronounce right here. Cardinality, yeah, cardinality, and even distributions aligned with the query. For the better one is like low category. Eventually distribute query requires gather. So where I have the same this one. Okay, the good way is used like for example for the ID is okay. It's a good. And also this is also example like based on the user ID we can separate the data. It's okay. And also order ID, right? It's kind of like index. But it's not good to sharding the like some Boolean point is premium or not premium, because you have to handle something. For example, if most of the user is not in premium, which means this database will access more frequently than this one. So there are so many requests to access this one, so it's not balanced. So same situation for this one, like create ad by the year. Because based on the current year, right, most people will just access to the recent year instead of the very old one. So which means the current database will access huge, more than the previous years. So it will encounter some problem. And now it's going to the 2026 now, so we can update here. So it's not a good way to do that. This 4. So we have better pick up the like user index, right? It's better to kind of like pick up the primary key in the database is normally it's okay. Yeah. Okay, so now we come into the next question, how to distribute data. So we have we can just based on the index numbers, right? So the user ID stuff from current here, from here, we can just distribute the data based on the capacity, yeah. And normally it's by the default we use like a hash key to hash it and send into the different the shadow database. And sometimes we will use like a consistent hash, right? So if hash pointed to the, like for example 16, it will choose the database 2, and we move the clockwise until hit the database 2. And this can average our database, the data into the different database. And also in the consistent hashing, there's a virtual node way to handle the balance. So it's a good way to separate the data, distribute the data. And also we have another way is called like a directory-based shared. So you have to create the kind of like a table and to store which data should belong to the which one. So this is also a way to handle the distributed data. But by the default, it's used the hash-based. Okay, so what's the challenge about sharding? So we have the hotspots. Hotspots. Let me pronounce it. Is this pronounced right?
Spots.
Spots, yeah. Spots. Hotspots. So this hotspots means when we have servers, right? So based on the user ID, for example, current here I have the user ID, very famous people on it. So it's very frequently to access it. So it's also will creating some problems. So the solution is we can create the for the special people, special ID, we can use the direction-based sharding to create that, and also create another shadows prepare for those people. This is what will be a better way to solve this problem. And another challenge is called cross-shared operations. So the service, right, it will aggregate all the 30s, rank, and return the top 10. So maybe we have in the shadow we have some posts based on the index 1, 2, 3, and this one is also 1, 2, 3, and this is another. For example, this one is start from the 1 to 10, and for here is 20 to the 30, and this one is 30 to the 40. But we want to pick up the top 10 popular posts. So maybe one of is inside here, and one of inside here, and one of inside here. So we have to collect from here, clear here, and then return back. So it will have multiple requires. So we have some solutions is we can use the cache, right, to solve these problems. So this and also another is called the denumerate. Also is a good way to solve these problems. Or you can change your shared key based on the different situation. And this is called the cross-shared operations challenge. And also it's called like another challenge is maintained consistency. It's a service, right? So you have to go to this shadow, and shadow you have to, when you, this is atomic, right? So you have to make sure every operations works fine. If not, just return back. If not, it's just a rollback. So for this, is also encounter lots of multiple requires. So there's a solution is called seg patterns. It's kind of like if not make sure the whole every operation is kind of like make sure current here. Okay, so this one is change. Right, so this one is commit. This one is commit. Is okay, and then it will go to the next step. And during this step is not good. Yeah, it's go to the next step. And this one is also will commit. And one of them find the notify is not work. Then it will create another like operations to return the Bob money. So it's kind of like separate the whole operations and commit one. And if they find some problem here, they will do another operations kind of like for here, right, minus the Bob from the 5. And for here, Alice maybe encounter some problems. He said, oh, I didn't receive the money. So which means the service got it notification, and it will send another operations to the Bob. Okay, so I got the message from the Alice. The service didn't get the money. So I need to return back the money for you. So it's kind of like I don't care. It's just commit it until encounter something. We can kind of like a hot fix, right? Later to fix it. Yeah. So shadowing in system design interviews. So bring it up in the deep dives when talk about the scaling, but justify storage, write throughput, and read throughput. You don't always need to shadow. Okay. It's kind of like for here you better to calculate what kind of sessions you have to share. So better for the do some computing here. And what you say is propose a shared key based on your access pattern, choose your distribute strategy, call out the trade-offs, address how you will handle the group. Okay. This is called like sharding. Yeah. Thank you.